Hey, in this video we're going to talk about electron configurations. What you see before you here is two electron configurations. I just thought I'd dive right in. And what you see is actually kind of a complicated-ish address system for electrons. I guess the first question a person would have is, where are the electrons represented here? And probably the easiest thing to point out with this is that there's a self-check. First off, we're assuming that these guys are all neutral. By assuming they're neutral, we can say that, okay, if potassium, for example, has 19 protons, or carbon has 6, it would have the same number of electrons. So carbon would have 6 protons, 6 electrons, and potassium, 19 protons, 19 electrons. So where are the electrons in here? Well, the electrons are up here. They're the exponents. And the first thing you should notice about this is that you can add up the exponents, 2 plus 2 plus 2, and that should add up to the number of electrons we have, 6. That one does that. So that's the first thing to notice. Check it out with potassium. See if it works again. We got 2, 4, and 6 is 10, 12, and 6 is 18, and 1 is 19. So that one checks out too. So the first thing we know is that the exponents are the electrons. And when you add them up, they should add up to the total number of electrons in the substance. So to try to make sense of the rest of it, I'm going to take a simple example. So I'm going to slide us up, and I want to talk about hydrogen. Hydrogen is super simple. 1 proton, if it's hydrogen 1, there isn't even a neutron, and if we're assuming that it's neutral, it has 1 electron as well. Its electron configuration would look like this: 1s1. And here, I'll make that look a little nicer. There we go, 1s1. So like I said before, this number up here is the electrons. And if you add up the exponents, it should equal the number of electrons we have, which is equal to the number of protons. So that's going to be 1. That checks out. But what about these other two things? This big number and this letter S. And in the previous example, we saw that there was an S, there was a P, there's also 2 others that we'll cover. Well, this number 1, this big number 1, actually conforms, is something called an energy level. Energy level. The lower the number, the lower the energy. You could also sort of make the statement that it gives you a rough sense of the distance from the nucleus that the electron is sort of flying around in. So it gives you a rough sense of distance from nucleus. And think about it for a sec. If it's really low energy, it's not going to be able to really range far from the nucleus. The electromagnetism is going to pull it back. So low energy, lower distance from the nucleus. It's closer to the nucleus. These letters are a little different and interesting. They're kind of what's added on to this whole idea of quantum theory from the Bohr model. In the Bohr model, we just had nucleus, and we had rings around the nucleus, and we said, okay, electrons are flying around in these orbits, and that's kind of that. Well, quantum theory takes a different approach. Let me get this out of here. What quantum theory says is that you can't really know where an electron is. You can just kind of say where it is most of the time. This letter here tells us, let's see, we'll go with this brown color. It's the shape of the cloud. Now when I say cloud, that's kind of like a 3-dimensional area. So it's the shape of the cloud the electron is in most of the time. So take that in. Think about it for a sec. What this whole electron configuration is saying, what this whole guy is saying in total, is that you have one electron, that's the exponent. It's in the energy level that's closest to the nucleus, it's 1, it's the lowest energy level, and that it's flying around in a cloud of shape S. Now, the next sort of thing you're probably asking is, what is the shape of the S cloud? An S cloud is going to be roughly spherical. So what that means is there's a sphere around the nucleus, and that the electron is flying around in that sphere. Let's kind of shift this down, and we'll take a stab at drawing it. So here we go. What you'll often see is, here's a nucleus, and when people tend to draw the cloud, they tend to just draw, for S, a circle. That's an ugly circle. Let's try it again. Here we go. So, for hydrogen, the electron could kind of literally be sort of anywhere within our sphere here, flying around, very nearly the speed of light. So the S is a spherical cloud. A P is a kind of lobe-shaped. Whoa. There's also two others. One's called D and one's called F, but they are complicated shapes. And it's actually not one shape at all, but it's kind of a conglomeration of a number of different shapes. So, again, let's slide back up to this, because this is kind of what I'm asking you to kind of, excuse me, get out of this video. The three parts of an electron configuration are the energy level, which is the number, the shape of the cloud, which is the letter, that's again the cloud that the electron is flying around in, and the exponent, which is the electrons. And the other important thing is that when you add up the exponents, as we did here, they add up to the number of electrons. So that's where we'll start, and we'll work from there.